Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to first of all thank Tableau Software for their sponsorship of today's event. Tableau has been a longtime supporter of the Data Science Central community, and we're honored once again to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including LavaStorm, EMC Greenplum, Alpine Data Labs, Hortonworks, and Splunk, to name just a few. These past webinars are available on demand at datasciencecentral.com. If you do not have the opportunity to view them, I would encourage you to take a look, as they do provide some very good perspective into our industry specific to the topics discussed. Today's webinar is entitled How to See and Understand Big Data. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have a single panelist that I'll introduce to all of you in just a moment. We should have about 15 minutes of Q&A following the presentation, and you can find this recorded event on Data Science Central within about a week. I would also like to encourage our attendees to provide questions directly to me throughout the presentation. I will be reviewing them and presenting them on your behalf with the time remaining. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I will be your host for today's event. I'm very pleased to introduce today's presenter, Jacques McKinley. Jacques is Tableau Software's Director of Visual Analysis. At Stanford University, he pioneered the automatic design of graphical presentations of relational information. He joined Xerox in 1986, where he collaborated with the User Interface Research Group to develop many novel applications of computer graphics for information access, actually coining the term information visualization. Much of the fruits of his research can be seen in his book, Readings and Information Visualization, Using Vision to Think. Jacques has a PhD in computer science from Stanford University, and Jacques, we're very pleased to have you with us today. In today's presentation, Jacques will explain what research and practice have taught us about designing great visualizations and dashboards, fundamental principles for designing effective coordinated views for yourself and others, and how to systematically analyze data from multiple databases using your visual system. Jacques, we're looking forward to your presentation. Thank you again for joining us. I'm going to hand the control over to you. And
Thank you very much, Tim. Yeah, let me
My pleasure.
Show my screen. And welcome everyone to this talk. Big data has been in the news a lot lately, and you might be a person who's very skilled at the techniques and technology, or you might be a person who's trying to understand how to take advantage of the activity. This talk is for all of you. What I'm going to do is give you very concrete ways to understand how you can use your visual system to work with big data. But I'm going to start first by talking just about how to see and understand data of all types, not just big data, and then I'll get into the big data part. And we've done a lot of study of people working with data and developed a particular model that describes this, which is called the cycle of visual analysis, which is shown here. At the top, you see a task that data might be relevant to, and I think all tasks can be enhanced by use of data of one type or another. Given that task, you need to go get the data relevant to your task, and then you want to translate that data into a visual form, because the human visual system is very powerful at working with data. It's much easier for people to work with data when it's presented to them visually as opposed to when it's just a pile of numbers. You look at the data view and develop some insight, and then the final step in the cycle is to, given that insight, to go off and act on it. Now, the real point of this diagram is actually that although we try and go around this cycle in that in those steps. The reality of it is there's a lot of backtracking that goes on. So all the little gray arrows on the inside describe the reality of what people actually do. They'll get some data, they'll put it into a visual form, and look at the data view, and it figures. They'll realize that they don't have the right view, and they may need to go choose a different data view. Or they may look at the data view and realize they don't have the right data and have to go off and get different data. And what's really interesting is that even if you've gotten the right view and the right data, and you've developed some insight about your data, you will need to go off and act on it. And almost always that action needs to be to share the data with somebody else. And when you start sharing your insight with someone else, you'll often find out you need additional views to tell your story, and sometimes even additional data to tell your story. So this is the process that we're trying to support, and this is what you go through when you're working with big data. And I'm going to give you a concrete demo to give you a sense of what visual analysis is like. And I'm going to demo a particular data set that I find people can easily relate to. If you cast your mind back, you'll remember a couple of years ago there was a U.S. Airways plane that hit a flock of birds and had to do an emergency landing on the Hudson. Well, it turns out that the FAA has a wildlife strike mitigation working group, and they've been collecting reports from pilots about the strikes on their airplanes. And this down here at the bottom of the slide, you can see the access database that they've collected. And this is just the typical kind of data that people are trying to work with when they're trying to answer particular questions. So you can see on the left here, there's a column describing days, and then you have string columns like airport and operator, and quantitative columns like height and speed. And every row here is a report from the pilot to the FAA about a bird strike. Now, you know, you could imagine that you're sitting there wondering, gee, is it safe to fly? I just heard about this. But there's about 100,000 rows of data here, which for people is a lot to get in your head at one time. If you're, know how to type queries on a database, you can actually work with this, but most people can't, and everyone will be faster if they use their visual system. So I'm going to show you how you would do that using Tableau, which is the, it's a typical tool for being able to answer these sorts of questions. So when you bring that data set into Tableau, you'll see that it's actually got a bunch of columns. So there's information about the aircraft, the airport, the amount of damage, flight date. If I scroll down here, you'll see, there's other information. There's even descriptions of the species involved. And then down here, the quantitative columns are organized into a panel called measures, where you have the cost, the feet above ground, and then the number of strikes. And the basic way to explore this data is simple drag and drop, where I can drag out and drop the number of strikes, in this case on the row shelf, and you can see there's about 140,000 rows here. If I drop it on the column shelf, then I can orient my bar the other way. And for this particular scenario, you can imagine I can pull out the amount of damage field, since that seems very relevant to whether it's safe to fly, and drop it on the row shelf, breaking those bars apart. I can also put the amount of damage on the color shelf and give you a little sort of visual story about this. And as you can see, about 32,000 of the reports to the FAA, the field amount of damage was null, which means the pilot didn't even bother to enter anything. So that probably means that there was no damage. 84,000, the pilot said none. And then there was 13,000 for minor, and then medium substantial, then a very few number destroyed. So that makes it very clear immediately that we can probably think it's fairly safe to fly. But what often happens when you deal with data like this is additional questions will come in mind. And as I was reviewing the data here, I noticed the cost column. And so it's a natural thing to ask, what is the relationship between the number of strikes and the cost of those strikes? And I can drag the cost out and put it next to the number of strikes, and I can visually see inverse correlation here, right? Which is the number of strikes is dropping, whereas the cost of those strikes is going up. which isn't surprising since what's organized here is the amount of damage. But what was a little surprising is the size of the substantial cost, which is about $500 million. And now I've suddenly realized this is why the FAA has a wildlife strike mitigation working group. It can be very expensive. So this is the basic exploration that's visual analysis. There are other questions you might want to ask of this data. And so let me go on and ask some of those. Like if you think about it, maybe particular geographic locations are more susceptible to bird strikes. Like I live in Seattle, Washington State, which is a bird migratory zone. So should I be worried about Washington State? And then another question you might ask is the when question. You know, maybe it's getting worse. Maybe that's why I finally heard about this. So you can go and answer those sorts of questions. And I have an origin state field here, which I can drag out and build a statistical map. If I drop the number of strikes on color, we can see a filled map presentation of the data. Or I can switch it to size shelf. And we can see here that Washington State isn't particularly out of variance with other states. California, Texas, Florida have a lot of bird strikes, but they're also very populous states, so I'm not surprised with that. Colorado isn't a populous state and seems to have a lot of bird strikes, but I know it's a hub for flights going from east to west coast. Anyway, that's the kind of analysis you can do using your visual system. And then finally, there is trends, and we can do the same thing as before. I can drag out the number of strikes and get the flight date here and drop it on the color shelf, on the column shelf, and you can see that the trend has been upward except for a drop at the end. And when I ask people, you know, what's interesting about these lines, one of the things they notice is the drop, and then some people will guess that the reason for the drop at the end is because of incomplete data. And you can see that very easily by drilling down to quarter and month. And you can see, by the way, for 1990 here, there is more bird strikes in the summertime reported than in the wintertime. Birds are more active in the summer. And if you scroll over to the end, you can see that the last year is incomplete. And so that explains this big drop here at the end, which you can, you know, we can remove that. And then there, notice the upward increase. We'll talk about that later in the talk. I'm going to come back and demo this data set some more. But you know, there are some hypotheses as to why that the number of bird strikes reported has been going up over time. Anyway, that's visual analysis, and that's a really good way for people to work with data. And it's not just about aha. It's not about the aha of oh, that's why the FAA has a wildlife strike mitigation working group. One of the real values of using your visual system is the speed at which you can work through data quickly. And so that's a major thing. Humans' visual systems are very powerful. So let me talk real briefly about how do we empower individuals and groups to analyze and share data effectively. Well, we want to support the cycle of visual analysis, and I'll mention 4 techniques in particular: incremental, direct, expressive, and unified. Incremental, you just saw me do this. It's the process of really easily and incrementally changing how you're looking at your data. So you saw me do this, where I started with a line chart. I broke it down into a sequence of lines, and then with another quick drop, I could look at what's called a small multiple table of different you know, of the data broken down differently. This incremental process is what makes it very easy for people to explore their data and understand it. Direct interaction is our goal, is the ability to work directly with the data, make the tools disappear because they get in the way of your ability to think about your data. So here, if I click on a mark in the western region, I can highlight the rest of them so that you can compare them visually against each other. Expressive is very important. You'll notice that in the demo I gave you, I had there was not a single view that answered my questions. I went from a bar view to a line view to a map view, back and forth. So you need to have technology that's expressive. And Tableau is based on an algebra for describing data views, and these are some of the views that it supports. Notice in the lower left corner that Tableau that I included a table of data. Tables of data are very useful views if you want to know the precise numbers. So that needs to be part of the algebra. And furthermore, it should be very easy to move between these different types of views because you don't know which one is going to answer your particular question, and you might need to move through a bunch of them to get your understanding of your data. And then finally, unification with the database, which is this point is actually very closely related to today's talk. In the upper left here, I talk about traditional reporting tools. This is where most of the world is right now, where there's highly performant databases or data warehouses in a company that IT can type queries at, and they can also specify reports which are sent out into the organization. Given what I've told you, those reports are most effective when they have graphics in them. However, the problem is that you might get a report that doesn't actually have the data that you need to answer your particular question. So the second approach is to have highly interactive graphical tools for working with data, but the traditional form of this is the data is poured into these interactive tools, and the problem with that is that you will sometimes have to go back to the database to get them. Tableau is an example of a new generation of this, where we have a highly interactive graphical tool that's directly connected to the sources of data so that you can interact with it in real time. Now, before I go on and talk about big data, I want to deal with two of the stereotypes that people typically have about visualization. The first one is that visualization is only for big data. And that's not true. You can actually, I'm going to give you a demo of this data set. This is the entire data set here. You can see that there's, about 35 rows and only about, 8, 10 columns here. And yet, even this small amount of data, it's, relatively hard to get it into your head all at once and deal with it. But if you put it into a tool like Tableau, you can start to process it very simply. So you see we just have a small number of columns. We have, order, this is sort of sales data. And I can drag out product category 2 and drop it on the rows shelf. And I can grab sales here. And so here are my sales for my different product categories. And I can drag out profit and put it next to it. And I can sort. And when I do this, we see that that sales and profit, which probably should correlate, don't actually correlate. We can see here that the storage sales is quite high, but its profit is low. And we can also see that appliances here have a negative profit, which is obviously something we should worry about. And so what you want to do with the visual analysis technology is just explore and try and figure out whether there's reasons for this. So I can drag out ship method here, and we can see that appliances are being shipped by express air, which may well explain the negative profit value here. Now that doesn't explain the differences here between the sales for the storage and the profit for storage. So I can go off and look at some of the other dimensional data here to try and understand that. So for example, I can drag out ship container, and we can see that there's a large amount, so that this blue bar here is large box, and large box is precisely the part of the gross profit that's negative. If this were positive, then this bar would have sorted up higher than it did before. So we get good clues very quickly with about what might be the problems going on here by using our visual system to explore this data. So that's one stereotype, which is that you should only use visualization for big data. We could actually use it for small data like this. The second stereotype is that you need visualization for complex data. You could argue that although that wasn't a lot of data, it was fairly complex. And this is, data can often be very complex. So this is a diagram of some ETL process for pulling data out of transactional databases and building up a huge data warehouse. Now, visualization can be very useful for that, but it can also be useful for very simple data. And so let me show you a data set here where I have precisely 2 columns, not more, nothing complicated about it at all. And let me show you what that looks like in Tableau. So let me go to a clean sheet, and here's the data. Exactly 2 data sets. 2 fields. There's an order date and a sales date. And so let's start to explore this. And so I can drag out the sales total, and then I can see that over 4 years there's been a drop in my sales, which is a worrisome thing, which makes you want to drill down a little closer onto that. So I can break it down by quarter, and we can see that there's some quarter variation. I can look at it a slightly different way. If I organize it this way, I've now lined up the years so that I can see the years lined up like this, and I can bring out the date one more time and look at it from a weekday point of view. And now we start to get to somewhere pretty interesting. If you look at Saturday here, you'll see that Saturday is up, particularly in the 4th quarter of every year, except for the last year here, where it's down. And Saturday has been actually a very good performer. I can see that by looking at other Saturdays in past years as well. And so it may well be that I should be exploring Saturday and why that I haven't actually got my recovery working for the weekends when there could be more traffic. You get the idea. So now the rest of the talk is going to be organized into 4 parts. I'm going to talk about, the way it's organized is I'm going to think about how data can be big in various ways. Data can be very wide, data can be very tall, you can have data from multiple sources, and then I'll finally get to the current focus on big data, and I'll talk about big data specifically. But these techniques all apply to big data. This is just a way to sort of organize it in your mind so that when you see, when you confront a particular problem, you know what techniques you can use to try and deal with it. So for wide data, the problem with wide data is that you're dealing with a lot of fields at the same time. And what you want to avoid is building really complex views. So you'll see down here in the left-hand corner is a very rich view where lots of fields of data are put into that single view at the same time. Now, this has been done traditionally back in the old days when people were sharing data views with print, because the printed view would be static, and so people would want to pack as much data into those views as they could. But the problem is it's very hard for people to understand these kinds of views. And on the lower right-hand corner, I just point to you that in Tableau, you can see that you could actually build really complicated views because you can put fields on the column shelf, the row shelf, the color shelf, the size shelf, the label shelf, and the shape shelf, and also have additional fields for detail and tooltip. And as a result, you can get really, really complicated. And so the key technique here is to avoid building really complicated views that are very hard for people to understand. And you've actually seen me already in my demo use one technique to deal with this, which is what are called small multiple views. And so in particular, I built a small multiple table where I had a number of strikes against cost, and notice that each individual panel here is simple and clean and easy to understand, and they're organized into a structure, a table structure, that allows you to easily understand the data next to each other. Another form of this is when you nest dimensional structures and you end up with the panels here. In this one, it's the amount of damage and then by time of day, and so you can look at it that way. So small multiple views are a very effective technique for reducing the complexity of individual views and dealing with wide data. Another technique is called dashboards. And I reach all the way back to this very famous view by Charles Menard of Napoleon's March on Moscow. What you have here is the width of Napoleon's army when he headed towards Moscow, and here's Moscow on the right. And then the black line coming back is the army during the retreat from Moscow in late October. Now, this is actually a small multiple view because down at the bottom here is the temperature line of the dropping temperature in the Russian winter during the retreat. And Menard has actually lined up particular points here to help people understand the view. This is a brilliant design because although there's a lot of fields, a lot of aspects of data encoded here, the individual panels, the two panels here, are very simple, and then the coordination gives you the ability to understand the multidimensional data you're looking at. So you can do that in Tableau as well, and so I'm going to give you a little demo of how you can build dashboards in Tableau and also set up very easy coordination between the various panels that you create. So let me go back to my demo. And I'm going to go create a dashboard view, and so here's an empty thing. I can drag out the existing sheets that I've started with, and so here's the map view that I built before, and I can put the trendline view down here at the bottom. And so you can see already the power of a dashboard, which is that this is focused on geography and this is focused on time, and these two views are very easy to understand at the same time, and I can reach into the data both from a geographic point of view and also from a temporal point of view. And I can also set up coordination very easily. So in particular, I can make this map be a filter for the dashboard. And so here I can actually focus in on California, Washington State where I live, or Hawaii, and we can see that there's very different trends for those different states. And so you could imagine that you could build up a very effective little working environment where each view is very simple, and then you use the interactive capabilities of a modern digital data display to explore more deeply into the view. So that's wide data, and those are techniques to use for wide data. The next challenge is tall data. Now, with tall data, the basic technique we use to deal with tall data are two. One of them is to filter the data down to a particular region or whatever topic we want to filter it down to, and the other one is we can aggregate the data up, and so that we can deal with data in aggregated ways. The challenge is for tall data, these computations to filter and aggregation can be very expensive to compute. Now, if you happen to have your data in a fast database, you're good, right? Because databases are 30-year plus technology that is designed to do those kinds of computations really, really quickly. And then you can get this highly interactive cycle of visual analysis that I demoed here, and you can then explore your data really quickly. However, many people have slow databases. Like what happens is a data warehouse will grow bigger and bigger to the point where it can't process the queries quickly enough, and so you end up having very slow interaction back and forth between your visual tool and the database. And then finally, lots of people, actually part of big data is many people are now starting to deal with data that are log files or text files of one type or another. They don't actually have a computation engine around to easily process that data and create an interactive experience. Now, the standard technique for solving this is to put an intermediate computation engine between the slow data sources and the cycle of visual analysis. So Tableau has built a database that it uses internally in its application, which we call Tableau's data engine, which I would like to demo for you. It's a very modern database architecture based on column orientation and takes advantage of using compression and knows about the memory profile of the computer that it's running on. And so let me show that really quickly here. Whoops. Oh, actually, that wasn't the right thing to have done. Now, I want to go back to sheet 2 here, sheet 3 here. And I promised that I would talk about this upward increase. When I ask people, why would the reported strikes to the FAA be going up over time, I typically hear 3 hypotheses. One hypothesis is that there's more reporting going on. Pilots are reporting. Another hypothesis is that there's more flights, and that's what's causing the increase. And the final hypothesis that I sometimes hear, which is amusing, is that there are more birds around, but I don't happen to have a bird database, so I can't explore that one. You can see the more reporting, by the way, really easily by dragging out the amount of damage and putting it on the color shelf. And what you can see is that the null has been going up, the none has been going up, the mine has been staying flat except for a bump here started in 2003, but the medium, substantial, and destroyed are flat. I think this suggests that there's been more reporting going on, particularly because there was this huge jump here in 2008, which was when the U.S. Airways plane was in the press because of the emergency landing on the Hudson. And I think pilots decided that they would do more reporting about, oh yes, I know a bird hit my windshield, didn't do any damage, but I should tell the FAA about it. But to explore the more flights hypothesis, we need to have a flights database, and you can get one of those from the FAA. And here is this is the on-time arrival data that you can get from the FAA. You can see it's fairly typical. You have information about the airline, the arrival time, the destination state, the quantitative data about the delays, the origin airports, various types of different things, and the number of flights. And I can drag out the number of flights and drop it here. And one of the things to notice immediately is this is a much bigger database than the other one. This is every commercial flight between every city in the United States, and it has about 144 million rows of data in it. And so we can look at that over time by dragging out flight date and dropping it on the column shelf. Now notice the delay here. It takes a couple of seconds to scan through all 144 million rows and aggregate them up at the year level, and then show that. So that's what you need a performant data technology like the data engine to deal with, is to do those kinds of computations. By the way, notice that there's a drop here in 2001, and then a further drop here starting in 2007. This is obviously 9/11, and this is the recession here. And you can actually drill down, and this is my way of demoing that you do have to do these computations, right? We have to rescan the 140 million rows at the quarter level, or rescan them down to the month level, and then you can see the data like we showed before. By the way, it's pretty flat, typical dip in February, and then if you scroll to the right, here's the drop for 9/11, and then if you scroll here, this is really amazing thing. So here is a drop in August 2008. This is when Lehman happened, and who would have thought that Lehman would have had that immediate impact on commercial flight traffic? And as you can see, we're still in recession even 4 years later. So we haven't had the recovery, and I'm pretty sure that the flights is somewhat a lagging indicator of that. But hopefully we'll see it go up one of these days. So that's about dealing with tall data. Now what I want to talk about is data from multiple sources. Now, typical people who are working with databases of one type or another also typically have data in some other source. Like you may have your actuals in your database and your budget sitting in a spreadsheet that you have on your side. And of course, you'll want to combine these two together. This is a natural part of dealing with big data, which is that data comes from many different sources, and you have to combine them together at the same time. Now, at the row level, it can be very hard to join data tables together. I've been demoing flights and strikes here, and if you think about it at the row level, they're hugely different, right? Flights are just regular commercial flights every single day from various airports, whereas strikes is a completely episodic database. There may be no strikes on a particular day, and then you might have a day with multiple strikes from a particular airport, and trying to combine these together at the row level is very difficult. And yet, you're going to want to ask questions about whether strikes and flights are correlated with each other. We were just doing that, and so you need to have some way of combining the data from these sources together. And there are two techniques that are very effective. One of them is the dashboards I've already shown you, and the other one is by blending data together, which is a way of essentially joining the data at aggregated level with each other. So, so let me quickly show that. I can go back to the dashboard here, and I can, I guess it was sheet 6. So here's the data from the flight data. So I can have both the strikes and flight data together at the same time. I can also go to sheet 6, and I can actually combine the wildlife data directly with it. You'll see that I have flight date here, and there's a linking icon here to indicate that I have this field in play. And I can drag out the number of strikes and drop it, and we can look at the two trends against each other at the same time. And so what's going on here is that when you aggregate both of these data sets up to the year level, the numbers are can be compared visually against each other, and we can see that they're not there's not a correlation, at least in the first decade, between these two trend lines. Now I want to talk about big data a little bit in particular. The first thing I want to say is that big data is a huge boon to us. It's the basic architecture is a map-reduced architecture, a multi-processing architecture, where you can take the data and map computations onto it, and some of those can be reduction computation. And the parallelism of the multi-processing architecture allows you to increase the amount of data that you can process. So it's about the scale of data that you can process. And since it uses commodity hardware, it's very low cost for in terms of the data computations that you can do on it. And people have been using it to process non-SQL data. The focus of it has been on data scientists. In particular, these are individuals who are very skilled in statistics, machine learning, pattern recognition, programming, and they can set up programs using the maps reduced architecture to do very sophisticated analyses of one type or another. But there are a couple of challenges. The first challenge is that there's a limited number of data scientists in the world, and so it's not easy to program map-reduced architecture to get data out of it. So you might well need, if you're don't have those skills yourself, you're going to have to go find a data scientist to help you. And the problem, of course, a related problem to that is if you have a basic regular question of one type or another, you still have to set up this complicated program to answer it. So there's a intellectual overhead cost to just getting any answer out of it. So the focus on data scientists is a valid one in that it allows you to answer sophisticated questions on data of larger scale, but it's not the only solution out there. The second problem is these computations that run on this architecture can take there can be a lag between when you write the program and when you finally get the answer. And lags are really, really hard for people who are trying to answer questions with data because it interrupts their ability to think while they're writing the programs and while they're waiting for the data to get back. Now I'm going to show you give you two little case studies of the use of Hadoop in particular with processing data. One of them was the flights data that I've been demoing all the way through this talk. If you go to the FAA and you look at the data that they provide to you, you'll see that there are text files, they're comma separated files, one for each month, and every row in that file, except for the first row, describes a particular flight on a particular day at a particular time. And this is just the top of one of the files. You can see there's the header row, and then you have a row for a particular flight out of Dallas-Fort Worth, Texas. And the challenge here is these are monthly files that have to be combined together. They're long, each file is long, and to actually do the kind of visual analysis I've been demoing for you, you have to combine them all together. So using Hadoop, the first thing to do we did was write a Perl script that would pull down all the data and put it in a local directory. And that's great. Hadoop processes the data in that directory really, really well, so that's really, really easy to do. However, you need to understand that some of the data is quantitative and some of the data is categorical, that the data has a particular format that needs to be processed correctly. And so what we ended up doing is we wrote a little MapReduce program that took regex patterns to actually interpret the data correctly, and so then we processed all the files so that they would be processed, so they would have a form that we could actually do analysis with. And then the final step was we created a bucketed table, because when the data is organized that way, you can actually do the real-time visual analysis work that we were doing on it. And so you end up with this situation. After you run that program, you have the data now sitting on disk in such a way that Tableau can directly connect to it and give the cycle of visual analysis that I've been demoing. The second example I'm going to talk about is some weather data that we got from the government as well. This data is XML files, where every single row in the XML file is description of weather data for a particular city. Now, the challenge of this data set, it's gargantuan for one thing, but the XML structure means that each of those rows has a very rich structure inside of it. And I've tried to diagram it here. What you have is a little description at the top about the particular city, and then inside the XML hierarchical structure, you have chunks that describe the weather for a particular day, and then inside of that day you have chunks describing the hourly weather for every hour of that day. Now this is this is a rich, complicated description, but it's not easy to do computations over it. So what we did is we connected to Hadoop via the Hive connection and used the XPath function that connection provides, and we did a connection using custom SQL statements that used lateral view explode. And what we did there was basically we took each of the rows and broke them apart into multiple rows, first by the date and then by the hour. And we picked out the hours and dates. And then in the actual Tableau description, we were able to write functions that would actually go pick out the individual values we wanted. So you can see here a daily function where we would pick out the max temperature in Fahrenheit, or an hourly function where we could actually pick out the cloud cover for a particular hour of the day and get that text. And then if you run this MapReduce, if you essentially have now described using SQL or just simple Tableau calculations, a description about how to interpret this XML structure. And so you can use Hadoop to actually create a data table. And to do that efficiently, we actually built a Tableau extract, as I described before. And to Tableau, it looks like you have a regular data table, like I demoed before, where you have information about the city, and then you have daily and hourly temperatures. Notice these are calculations. But once you extract them into the Tableau data engine, you can process the data efficiently. So this is the other major pattern for working with big data, where you run you use the parallelism to process the data, but then you put it into some computation engine where you can get that highly interactive cycle of visual analysis that allows people to work with it. So that brings me to my last slide. This is the summary of my talk, and I see we have time for questions. So what I talked about was the cycle of visual analysis as the basic way that humans take advantage of their visual system to work with data. And then I talked about sort of the way to think about working with big data. Data can be very wide, which is you can have lots of fields. And what you really want to do there is create simple data views, but combine them together with coordination. Data can be very tall, which the challenge there is that the computations over tall data can take a long time. And what you want to do is use databases or something like the Tableau data engine to do the computations efficiently. And then most people, when they're working with data, end up working with data from multiple sources. And so you have to have some way of bringing that data together. And so you can use dashboards or blending to combine the data together. And then finally, big data is all about this chain of computation that you can build up, either in your MapReduce architecture or also by including databases or other technologies to be able to give you that rapid way of doing your question answering. So thank you very much for sticking through, and I'm looking forward to your questions.
Thank you, Jacques. That was really great.
Thank you, Tim.
Impressive. We do have time for questions, and we've had several come in along the way. So I want to thank our audience again for their participation in answering the questions. And one of the first ones is really appropriate given the your last slide there. And the question is, humans tend to see patterns whether or not they're significant from a statistical or practical perspective. How do you address this when using a tool like Tableau?
Yes, so absolutely, people do see patterns and they might not be valid, but if you're in a tool like Tableau and you can use it to validate that the pattern is valid or not valid by continuing to explore on it. You can look for the correlations. In other words, you know, it may or may not be correlation. You can also run statistic models over the data as well to help you validate that. But it's the highly interactive interface that allows you to go beyond just seeing the pattern, but being able to get confidence as to whether you should trust it or not. Right? I mean, in other words, that's the key thing. Is the interactive tool allows you to both see a pattern, which is really important, right? There might be something there, and then determine whether it is actually something that you should act on.
It sort of validates it, sounds like.
Yes.
Another question is, how big can the data sets be for Tableau? Can it take up to 20 million or 30 million lines? I guess we're just giving it
so
very large.
Yes, it's a great question. So if you direct connect Tableau to a database, the key question there is the data computation engine able to handle data of a particular scale? So Tableau, for example, Tableau can connect to vendors that use multi-processing architectures like Teradata, Vertica, Netezza, and they can handle actually really large amounts of data, and you will get into that sweet spot if when you build your data views, you ask for data that's either filtered or aggregated such that the result set coming off the data engine, the computation engine you're using, isn't too big. Because if it's big, then you suffer the communication costs of the result set coming into Tableau and being slow. But as long as you're working with data that's either filtered or aggregated down to a reasonable size, and the data computation engine can handle terabytes worth of data, then you can do this real-time analytics. That's the real power of being able to direct connect to a data engine to be able to explore it.
Great. This is, I think, an appropriate question as well. So an attendee is asking, can you go over the available connectors for Tableau like Hive, Impala, Custom MapReduce, etc.?
Yeah, simplest thing to do for me is to go back to the tool and just click on the connect. There's the list. You'll notice that actually I don't see it in the list now, but we've been, my license doesn't have this right now, but we've been running the Cloudera Impala connector in beta, and in the next drop we'll probably take off the beta tag since Cloudera has now released Impala. But you have the list. Here's the list of the different data sources that we connect to.
Okay, very good.
I'll just leave that up for people to look at.
Okay, and I'll shift back to slides in a little while, but that should give everybody a chance to view that and take that list down. Another question is sort of a standard one, but how hard is it to get started? What are there steps? And then along with that question is, how long does it take to become proficient? So a multi-step question.
Okay, so the good thing about a tool that's incremental in that you can start out with simple views of data and then build up more complicated ones over the time is it's relatively quick to get started. In fact, in particular, what you should do is be focusing on the data and the question you're trying to answer, which is something that most people know about, right? They know what they're interested in, and they know something about the data that they're working with in terms of answering that. And then just drag those fields out and start looking at the graphical views, and you can get started pretty quickly. Proficiency is on the other hand, can take a fair while to get proficient. In fact, there's a huge depth, I think, to being really effective at doing visual analysis with data. And I would say, I'm still getting better over time, but you can get significantly proficient in 6 months. We see people go through a learning curve where they start to get really capable in 6 months, but they were immediately, within hours, being able to do work. It's just that, as you get more skilled, the questions you ask get more sophisticated, and then it takes time to learn how to do that. And the other thing that happens on the proficiency side is you start asking more sophisticated questions, and you start wanting to collect or change exactly how you're working with your data. You might even write calculations that are designed to be looked at the data in a visual form. So it's a great question.
Very good. Okay, here's another good question, I think. I'm a statistician, but not a data scientist. Which programming languages would you suggest to learn to better approach the data?
So I didn't quite get, was the person a statistician?
Yeah, the statistician, or he or she is a statistician, but not a data scientist. And they're asking what kind of languages you might suggest to better approach big data.
Well, I would start with I would start with a tool like Tableau, and I'm not going to recommend any particular vendor in terms of their programming languages or styles for them. I think you really should be driven by your data problems that you're working with in particular. And you can get quite far, I think, with really basic abilities in terms of writing simple calculations of one type or another.
Okay. And then I think we'll maybe let this be the last question and we'll start to wrap up. But
okay.
Are there any mobile interfaces?
Yeah. Now, the interesting thing about Tableau is, and that's a great question, is that Tableau has a product called Tableau Server where you can publish these interactive views, like I showed you with the map and the lines and whatnot, to Tableau Server, and then it will you can actually connect to it with your mobile device. It uses JavaScript on the client side, and you can get the highly interactive interface. And in version 8 that we just came out with, the same drag and drop experience that I just showed you running in the application here can also be done in the browser and including on the iPad. And so, the basic philosophy is you should be able to get access to your data wherever you are and be able to do analytical work. And so yes, mobile devices you can use them for this. Again, the obvious. Go ahead, Tim.
No, I was just saying. I thought you were wrapping up. No, continue, please.
One final point is, of course, if you're on a mobile device, you have to be very aware that you have a slow communication channel back to the server. And so even more importantly there is you have to filter and aggregate the data so that the data that's coming down onto the mobile device isn't too big. And I'm wrapped up now.
Okay, very good. I think I got to most of the questions. If I missed anybody, we will be sending all the questions directly to Jacques and Tableau. So rest assured you will get your question answered. I just have a couple of quick announcements that please mark your calendar for May 21st and our next Data Science Central webinar, Visualizing Big Data, sponsored by Pivotal. And then also, as I mentioned earlier, today's taping will be made available on demand viewing within a week, maybe just a few days, and you can find it on datasciencecentral.com on the lower right-hand side in the video section. It should also be made available on Tableau's site as well. This concludes and brings our webinar to a close. I'd like to thank our audience again for their attendance, thoughtful questions, and a special thank you to Tableau and to Jacques for sponsoring today's event, and Jacques for your insight into the topic. My name is Tim Madison. I'm very pleased to have been your host today and moderator, and I look forward to seeing you all again on May 21st.